Good afternoon, Mr. Mookerjee.
Afternoon.
Now, Mr. McIntosh.
Yes, thank you, my lord. Mr. Mookerjee, I've had a few questions from colleagues, which I think is probably a good time to ask them now. So if we could put the new document back on the screen that came up this morning, just as something to refer to. Now, the new line on that table, which is the purple line you've called overall Schiehallion rate per 1,000 admissions.
Yes.
And that obviously, the numerator of that comes from your table on page 24 of volume 21, volume 6.
Yes.
Previous page, please. Now, can we just check, as a yes/no question, do these numbers of infections include infections that were found in day case only patients?
No.
No.
They include all infections.
All infections. No, but what I mean is, within there, will you find the day case only infections and the overnight cases?
Yes.
Yes, both types. So just to use some examples for clarity, if a patient is visiting the hospital 2 or 3 times a week for a number of weeks, or as a day case, and they have a bloodstream infection of one of those organisms, they're in that those numbers.
Yes.
If a patient is in the hospital for 6 weeks as an inpatient and they have a bloodstream infection, it will be in the numbers.
Yes.
Right. We go back to the document from this morning. Would you agree with the idea that in order to rely on the new overall Schiehallion rate calculation, one would have to be sure that the comparator institutions were supplying admission numbers that included day cases?
Well, I guess the presumption is that the understanding of the word admissions is the same, and that the word admissions has been understood in the same way, and has been responded to in the same manner.
Because I suppose we can do a check. If we go to if we look at the bottom of this table first, we see cumulative admission numbers provided by Greater Glasgow,
Yes.
which range from, in complete years, from the high teens to 1900 up to 2,500 if we treat the pandemic year as an outlier. If we go to page 29 of bundle 21, volume 1, we see that, putting aside Great Ormond Street for a moment, the numbers are less than Cardiff and the Vale, less than Leeds, and a little bit less than Oxford. And so whatever they're doing, they're providing more admissions than Greater Glasgow are providing.
Yes, I think the basis on which the numbers are accepted is that the patient had an admission date assigned on the electronic system.
So that would include day cases?
Yes.
Right. The next question, if we go back to, we'll stay in this bundle, and we go to page 88. You make an observation in paragraph 2.62 that on comparing the first and second admission data set from NHS GDC, I noted admissions to 2A and 4B have remained fairly constant, apart from 2018, but not so for 2B and 6A, where admission figures have doubled, tripled, or in some cases increased 11 times the figure provided for the NHS Greater Glasgow for the previous year.
Yes.
Now, I recollect you discussing that with me at a consultation, and that's when you put this in. What concerns do you have about this change in the numbers, and what did you do about it?
Well, I'll answer the second part first, because it's a simple answer of there's nothing much that I could do, in the sense that I took at face value the admissions which were presented to me, in terms of the first spreadsheet, and I took at face value the admission spreadsheet where these numbers changed. Now, the reason why I noted that is because I could have accounted for, in my thinking, for a slight increase in the admission numbers.
Over time?
Yes, over time. But it is interesting that, and here, of course, I'm comparing the second to the first admission set, that I was surprised at how so different those aggregated figures for admissions were for 2B and 6A. And as I've noted, so I can convince myself of things having doubled when you account for more than just the overnight the admissions, but it increased by quite a bit.
I just wondered if you compared this. So we just look for a moment at the third column on figure table 3 on page 88, RHC Ward 2B, which for whole years has numbers 1700, 2200, 1700. And if we go back to page 28, the previous data set, which we're told only included overnight patients, was in the high hundreds.
Yes.
Could that not simply be explained by the fact that the normal patient in 2B is not an overnight patient, and therefore these hundreds of patients recorded here on page 28, the ones who are admitted, are being admitted, I don't know whether electively or as a surprise, but they're out of the ordinary for the general population of the ward.
Yes, and that is the understanding with which I continued,
Right.
which is that that I am surprised at the extent to which admissions to these wards were down to day cases and and to outpatient stays where you had the admission date there. But yes, my final thoughts on that were similar to what you said, which is that I have to accept that the change in numbers is accounted for by the fact that that a large proportion of those patients are day cases, and that they make up the large proportion of the admissions.
Right. And if we go back to the document produced this morning, is that anxiety that you had, described in the paragraph we've just looked at, part of the reason why you calculated the 2A and 6A infection rates, the green and the orange-yellow lines on this figure?
Absolutely, because what I wanted to do, in layman's terms, is to cut the data in a lot of ways, and to see whether the results I'm getting speak the same truth, or they have outcomes which are similar. In that, I adjust for by doing these different analyses. And here I've done it specifically for infections that are in inpatients And we know that 2A, 6A, and I've looked at the trend and I've compared the trend to, for example, how would the trend look if I took into account infections from all of Schiehallion. And what I'm trying to get from that is a feel for, are there inconsistencies within the data that are skewing the results?
Right.
And I don't see that, in the sense that largely the ratios are changing, but what is remaining the same is the fact that we started with a low figure in 2015, and then it then goes higher. So essentially what it's saying to me is that the data is representing what we know was happening at hospital level, no matter the way in which you cut it. If you look at 2A, 6A, you look at the entire Schiehallion unit, you take the old admissions, you take the new admissions, whatever you do, and however you cut it, the general the trend and the takeaway messaging remains similar, which is that you see this increase in the rate of infection at the Schiehallion, and then a gradual decrease. So generally.
So why did you not calculate what is now the purple line, the overall Schiehallion rate, in your supplementary report?
Because, and we go back to what we discussed in the morning, which is I'm taking into account infections for 4 physical spaces. And I should be taking into account the admissions for those 4 physical spaces and those 4 physical spaces only. And so I did that in the supplementary report with the new admission data. If I may say here that I've gone above and beyond that, I've given myself some leeway going, how does the trend look like if I put my head onto one side and I go, so wait for a second, let's just take the infections for those 4 units, but take into account all the admissions. In response to the criticism that the comparator units are doing the same.
And what do you derive from that this new exercise that you've done now with the purple line?
That the proportions have changed, but the takeaway message from the trend remains similar, in that there is a escalation in terms of the rate of infection, with then a drop off. The changes, of course, are the magnitude of that escalation.
Yes.
And the period of time over which that escalation is sustained. And
So
essentially, in layman's terms, how steep is the slope afterwards?
It's a smaller peak over a shorter period of time.
Yes.
Should there be any, how relevant is it that when we went back and looked at the 4 separate comparator units, we noted that as it were, the peak year in Great Ormond Street of 2019 was a rate of infections of 16.01 per 1,000 admissions. And although that's not the same year as we see the peak for the Schiehallion rate. It's not that different from 25.7. And so, to what extent do you consider this overall Schiehallion rate calculation to be significant?
Well, there is a difference in those two proportions, in that we were specific in our FOI and in my understanding of what was received from the comparator units, that what we want here are infections linked to the pediatric hematology unit, and we want admissions for that cohort of patients and for that cohort of patients only. And those FOR and those comparator units that could not do that said so.
Right.
So we're comparing quite a specific proportion where the activity matches the infections exactly in terms of space.
Yes.
And we're comparing it to a proportion which is the purple-pink line here, which is overall Schiehallion rate, where we've kept the infection, where we have retained the infections. We've been very specific about the infections.
Yes.
But we have inflated the activity to include the activity for the entire RHC.
No, we haven't.
I mean, sorry. By that I mean the for all four units.
Is there anything that arises from the fact that, to go back to page 29 of the bundle, thank you, each of these rows connects infections in one year with admissions in that year. And you seem to have said before this morning that the comparison is between the aggregate in the year.
Yes.
Not the aggregate, not the an overall. You haven't produced a single number. You produced a rate that varies each year.
Yeah, absolutely.
And so, what I'm just wanting to check is that obviously, I don't think it would be surprising if some people seeing your evidence looked at, to go back to the document from this morning, looked at the overall comparator rate per 1,000 admissions, or the cumulative incident rate, which is on the right-hand side, and go, well, the difference is only 2 and a bit times, 3 times if you round it. And the differences between the 4 comparators is 1 or 2 at times. So is this higher section in 2017 and 2018, without doing the water positive stuff, which we'll come to the water positive stuff in a moment, is it sufficiently high enough compared to the comparators either collectively or together or separately to be significant?
The answer is yes, because as I said, what has changed in calculating the overall the Schiehallion rate is the magnitude of the difference at each of those years when comparing the overall Schiehallion rate to the comparator rate. What is essential here is not to compare the overall Schiehallion rate to each of the rates of the hospitals that we are comparing to one by one.
Why not?
because you're then comparing the overall Schiehallion rate to a proportion made up of smaller numbers. So what makes up the rate of infection from leads in terms of the numbers is not enough in terms of making a rigorous rate of infection to compare to.
So if you've done the
Because the
exercise,
sample size is not big enough.
so if you've made the bigger sample to deal with your confounding factors, you're not allowed to go and cherry pick, introduce another fruit.
Yeah, absolutely. Yes. You cannot, and the reason you should not cherry pick is because, remember, what we are trying to do here is we're not trying to do a selective comparison. The whole point of this is that we're not trying to be selective in who we compare to, because that would open us up to being able to compare what was happening at the Schiehallion to a rate of infection from a unit which was performing really badly. And then of course the Schiehallion rate would look really good. The other way of doing it is that if you were comparing the Schiehallion rate to a unit which was doing really well in 1 year or 2 years, then the Schiehallion rate for those rates would look really bad.
So, for example, if you go back to page 29, if you compare the Schiehallion rate to the 2022 rate for Cardiff and the Vale, it looks very bad.
Yes.
But if you compare it to the 2019 for Great Ormond Street, it doesn't look too bad.
Sure.
And you're saying that's just the wrong approach to this?
That's a wrong approach because of the data that makes up that rate is you're sort of climbing up the iceberg here, and you then want to compare your iceberg in its entirety to the peak of the other iceberg. You lose the confidence in what you are comparing to, and so what is essential is to let the numbers do the talking. And by that I mean, when you are comparing to something, that something needs to, in this case a rate of infection, needs to be made up of sufficient numbers, both in terms of infections and the admissions.
Thank you. What I want to do, I think, now is to look at what you did in your addendum report. Because your addendum report, which we find from page 767 of this bundle, 21, volume 6, was produced in response to a suggestion by me that you should do some work around occupied bed days.
Yes.
Now, what I want to do first is just to check with you from page 768 what information you ended up with from the comparator hospitals on occupied bed days. I think it's in paragraph 2.1, section 3. So what did you have from Great Ormond Street?
Well, unfortunately, they had noted that they were not able to provide exact numbers for bed days.
Right.
And rather, even an institution like them, Gosh, could only provide a percentage or proportion figure. So essentially what they've done is they've done a rounding up going, these are the number of admissions in terms of all our pediatric admissions. And we think 40% for a given year were made up of admissions that were specific to the pediatric hematology oncology.
So they're not actually counting them?
They're not counting them.
Right.
And it goes back to the point that I was trying to make about how difficult it is to get an accurate bed days figure and what it entails, that you have to do the legwork. There isn't, in my knowledge, and I could be I'm happy to be proven wrong on this. There are not many electronic patient record systems that can accurately and automatically, so without human interference, will give you the activity data for a specific cohort of patients.
Let's look at Cardiff and the Vale. So effectively, their occupied bed days only went up to 14-year-olds.
Yes, so they were able to, perhaps because they're smaller,
Yes.
and so perhaps somehow they were able to get their bed days for the pediatric hematology oncology. But one of the caveats was that the age range was not the same as the age range we used. So
Right. On to the next page, 769. Leeds couldn't do it.
Leeds couldn't do it, and they said so.
And Oxford, what did they manage to do?
So Oxford were able to send the data for bed days
Right.
for pediatric hematology oncology. The problem is, and we go back to this issue of comparing something big to something small in terms of the numbers, is it's not appropriate to take to do a comparison to one unit, because you only have that unit to compare to, and the biases then get exaggerated, and they're not adjusted for in the same way if you had 4 units or 5 units or 6 units.
So you didn't do any, you couldn't calculate, you think, a comparator unit for Oxford?
No,
Right, Roger.
because all of my, all that what I have learned, so told me that you shouldn't be doing that.
Right.
Yeah.
However, you did calculate a infection rate for Ward 2A only using occupied bed days, and the results are on page 770. And what I wanted to ask you before we look at them is, why did you do it for Ward 2A only?
Because I wanted to be, I could be sure of only one thing, that Ward 2A was only made up of inpatients,
Unlike 6A.
unlike 6A or the others.
Right.
And so the numerator, going back to rule 1, the numerator then, in terms of the infections from 2A, would match the activity that I'm using, which is bed days.
For
Which
inpatients.
Which is a measure of inpatient risk. And it is important to say that what bed days does is it's a cumulative inpatient risk. You have to be in the hospital to accumulate that risk.
It's impossible. It's no use to work out the risk for outpatients, but it's a useful way of working out the risk to inpatients.
Yes, but you have to be sure then that the numerator is then made up of infections that are also linked to only inpatients.
Because you made the assumption that no outpatient would have their bloodstream infection test tag 2A.
That is the assumption.
We've not had any evidence to the contrary, but that's the assumption. Okay.
That is the assumption.
So we've got this table here. And so effectively, you've only really been able to do the work for the 4 years before the decant. And of course, as we've already discussed, the first year is a half year, and the second, and 2015, and the final year, 18, is a 2/3 year before decant. And so you report that, giving yourself rates of infection per 1,000 occupied bed days for inpatients, 1.75 2.79, 6.26, and 6.86. And that then is presented graphically on the next page. Now, firstly, does it matter for the validity of the first and last columns that they're only for part of a year?
No, because we take that into account by only taking the infections for the same period.
Yes, because the numerator and denominator are both limited in time the same way.
They're both, yeah. They are both. So for example, for 2015, the rate of 1.75 was only based on the infections from June to December, and it will be the same for the bed days.
Okay. So if we go on to the next page, what I wanted to explore with you, and I'm not sure I've asked this before, even at a consultation, and therefore I hope it's a good question, is if you look at these numbers here, particularly 2016, we have a rate per 1,000 occupied bed days of 2.79.
Yes.
Now, if we go back to the graph that was provided this morning, we have a rate, the green line, for 2A only, of a rate of 36.44 for admissions. And if we go back to 2015 at 23.62 compared to 1.75, and for 17, 166.67 compared to 6.26, and 18, 6.86. Now, I suspect you don't know the answer, but what sort of factors are driving the mathematical relationship between those four numbers and their equivalent four numbers of occupied bed days?
So I think the blunt answer to that would be that it's the magnitude of the difference from the rate at 2015 to 16, and then from 16 to 17, and then from 17 to 18. And so, you would have to, you would have, so for example, if I'm looking at this, I would go, okay, so the rate for 2A using the 1,000 admissions was 23.62. It jumped to 36.44. How does that look like if I look at 2A's rate per 1,000,
Bed days.
using our bed days figure?
And that's on page 771 of the other bundle.
It goes from 1.75 to 2.79. So that tells me that regardless of the way that I've cut the data, that both analyses are saying the same thing. And what they're saying is the rate was 1.75. It then increased to 2.79.
Can we go back to page 771 of bundle 21, please?
Now, I'm not going to do the maths in my head because I'm good at using a spreadsheet, but my mental math has suffered with age. But it's then gone from 2.79 and it has jumped quite a bit. Now, I was going to say it has more than doubled, but slightly, from 2.79 to 6.26 in 2017. And then I would say it has remained fairly consistent from 6.26 in 2017 to 6.86 in 2018. And so what is that telling me? That the trend of 2A so looking at the 2A rate of infection per 1,000 bed days, so seems to mimic the trend of 2A rate of infection per 1,000 admissions. By mimic, I mean, so essentially, if you follow my hand,
It rises slowly and then
rises.
steeply.
And then it's maintained.
Right.
Because I think one of the things that everyone gets very excited about is peaks and troughs. But I think one of the what is very significant here too is the fact that you have a rate of infection of 6.26 per 1,000 admissions for bed days, per 1,000 bed days. And in 2018, that rate has remained fairly consistent at 6.86 per 1,000 bed days. So even though one would say, okay, that rate looks fairly similar, but that is a lot of kids having, that 6.26 is made up of a lot of infections.
What's it in? I mean, this may not be the right way of approaching it, and I want you to slap me down firmly if this is the wrong way to approach this.
Sure.
Is it possible, using either of these methodologies, to work out the percentage chance of a young person having a bloodstream infection by admission or days spent in the unit?
Yeah, absolutely.
And is that a valid thing to do before you do it?
But that is exactly what that rate means. It means, and you can do it per 1,000 admissions, you can do it per 1,000 bed days. It is easier to do it at 1,000 admissions, and I'll tell you why. Because the human mind can make sense of the fact that if you take into account 1,000 admissions, you can sort of go, okay, this is made up of 1,000 admissions over a set period of time. And what you get out of that is, say a child over that year had a set number of admissions to the unit, and say for the case here, say for example, they had for that year they were admitted to the unit 1,000 times. That their chance of having a infection which was linked to a environmental bug was, we have to go back to, yeah.
Is the purple line?
Yes.
Would that mean that, conscious that this is a study produced from data that you've analysed with all the assumptions you've discussed, that for admissions in total, there are 25.7, a child admitted 1,000 times will get 25 infections?
Yes, so I mean, what it basically, so the way to read that is if you use another example, that if you were crossing the road 1,000 times, you would get hit by a car 25.7 times. That sort of is one way of looking at it.
Obviously, someone watching this might immediately think I should ask this question, which is, on the green line for 2A,
yeah,
how valid is it to say that in 2017, a child admitted to Ward 2A was looking at, am I right in thinking, a 16% chance of catching a bloodstream infection?
Yes, because you take 166.67 of 1,000.
And if we go back to page 771, conscious that occupied bed days is a harder thing to comprehend because each day is followed by the next day.
Yes, and you're taking into account it's not as clear a activity marker as a admission.
And I suppose it's a bit like that statistic that one used to read about of pilots in a war. They have to go and fly their plane 100 times, and if it's a 1% chance of being killed 100 times, it rapidly becomes a certainty they're not going to complete the 100 missions.
Yeah.
So if you look at this table, what is the number that draws out of the percentage chance of a child occupying a bed in Ward 2A in 2017 of having a bloodstream infection, catching a bloodstream infection that day? Or was that too precise a question to ask?
That is too precise.
Is there a better way of phrasing it?
The way to phrase it, and there is not an equivalence to admissions, where you can almost go that each time I am exposed to the hospital, and if I count all of those exposures, what is my risk?
Yes.
Here, roughly, very roughly, you're sort of saying that if a child spent 1,000 or the equivalent of 1,000 bed days,
Yes.
that their chance of infection would be 2.79. I am hesitant to sort of go down that route,
No, I
because
appreciate
I don't think that there is that unlike admissions, that the way in which or what bed days gives you is a cumulative risk of just staying in a bed and all the interventions which are that you are accumulating.
Because I'm conscious that there may be somebody watching this who's thinking of this piece of mathematics.
Sure.
That they can identify how long either an average patient or a particular patient spent as a inpatient in Ward 2A in, say, 2017. They have a number of days. They count them up. They multiply that number of days, or they divide it, I suppose, but they factor it against 6.26 as the rate per thousand. They come up with a rate for those 27 days. And that is a number. I'm not going to do the number now, but you can see how it might be done. Do you have any comment on the validity of that?
I think what I'll say is that is one of the reasons why the communication of risk is a difficult matter and a confusing matter, and that there are ways in which to understand the world, in this case the risk of infection, that allow you to segue from a rate to a risk easier as compared to when you start looking at things like bed days. What I will say, though, looking at figure 1, is, and conscious that we haven't compared this, and we haven't been able to compare it to comparators for reasons that the comparator institutions have been clear about, that they have been unable to give us the bed days. That if I was looking at that chart, and I'm looking at it now, what I understand from it is that the risk of infection, if you want to use that word risk, increases from 1.75 in 2015 to 6.86 in 2018. Both as a trained epidemiologist and as someone who might have a kid who is going into a hospital, and if that was presented to me, and you can see a lot of these things on charts, and that would concern me, because it just says to me that, okay, in 2015 the rate was 1.75. It increases, but okay, it might be within a ballpark figure. So in 2016, but what is happening in 2017 and 2018? Now, of course, the surefire way to understand how unusual the rate in 2017 and 2018 per 1,000 bed days is for 2A is to have been able to compare it to other units.
But there is one comparison that you can make on the previous page, which is, or can you? Sorry, page 70. 770, that's it. In 2022, there are 4,299 occupied bed days in the new unit.
Yes.
And there are no infections.
There are no infections.
Yeah. What I want to do is go back to the table that was produced this morning, and before we deal with water positivity, what do you think that the new line, the purple line, tells you about what is going on from an epidemiological perspective?
What stands out so bluntly is that something was happening in 2017. Because that rate is an aberration as compared to the other rates on either side of that, both 2017 and 2018. But the eye is drawn to 2017. So, and I have looked at these sorts of graphs for 14 years. That to me would say that something was happening there, and I want to know why we had that peak. And the other thing that I would say is something was happening there, and it seems to me that something was corrected for, or something happened, or some changes were made, something happened better. That after that increase, let's call it the norm, in 2017 and 2018, the rates go back to 8.06, 5.87, 4.18.
Which are less than the comparator mean.
Which are less than the comparator. So so if this was completely new to me, my hunch would be that there's been some sort of quality improvement program. That if everything else has remained the same, that people have responded to that escalation, and things have got back. The thing I'll end with is, and I always say this regardless of where I am, that just because a rate of 8.06 in 2019 looks less than a rate of 17.48 in 2018, and that looks less than the rate of 25.70 in 2017, does not mean that the rate of 8.06 in 2019 should be ignored, because it is still a lot of infections in a very in a population of patients that are already
On one.
yeah.
I wonder if we can just ask one more question before we move on to water positivity. We've discussed what might be what inferences can be drawn about risk for the inpatients and what probably can't be drawn about risk, and what issues you have with those approaches. I wonder, as you look again at the new line, the purple line, if one is trying to test the hypothesis, which I recognize wasn't entirely your hypothesis, it's part of it, that having an inpatient stay gives rise to an increased rate of inflection, how helpful is the purple line in working out the answer to the question about inpatient stay? Does that contribute at all?
Yes, because I mean, if you you're with specific sort of with specific reference to inpatient risk, I would go that I know that 2A infections were inpatient infections. I looked at a rate of 2A infection rate per 1,000 admissions. And I can see that the trend in infection rate increased from 2015 to 2017. And I compare it to a broader rate of infection in the new, purple line. And I see a similar escalation of risk rate of infection from 2015 to 2016 to 2017. What that tells me is that we know that in terms of the infections that we included all infections. That no matter how we cut it, we can say that there is a risk, and there was a risk to the patient. Whether you take a strict Ward 2A infection rate made up of infections only linked to to patients who are inpatients, or you take a broader cut of data.
Okay. What I want to do is to move on to the water sampling issue. Now, conscious that you did this twice. The first time you looked at water sampling and the correlation between the water sampling and the infection rates, it was the original chart. The one that was when GGC produced the original data, which only include overnight cases.
Yes.
And of course, the infections include day cases. And so there would have been a increase. The infection rate would have been artificially higher. You're nodding.
Yes.
And you then recalculated that once you'd produced the green and yellow lines on the chart that's on the screen at the moment. Yes. And we find that on page 92 of the bundle in your supplementary report. Before we go into what it says at this third bullet point on page 92, I wanted just to talk a little bit more about correlations because
yes.
What does correlation have the potential to tell us about the correlation or association between, in this case, the water positivity and the infection rates in inpatient wards?
What correlation is giving you is the degree of association or the closeness of the relationship between these two time series. The first the exposure time series, which is the water positivity, the blue bars, and in the foreground the time series that is made up of the rate of infection. And what the correlation tool is able to do is it's able to take the data points, which I should note that each of those points in data, of which we have,
We go back to the document from this morning.
we have for infections, we have 8 of them,
In which year?
one for each year from 2015 to 2022.
Yep.
And for water positivity, we have it for 2015, 16, 17, 18, 19, and 20. Now, each of those data points, and I'll get to the caveat regarding why I didn't include 2020 in my correlation analysis. But each of those data points, my point is in itself a aggregation. In the case of water, those 6 data points are made up of 4,759 water samples.
Over the 6 years.
Yes. And 500 of those 4,759 water samples which were positive. For infections, the 8 points of data, 2015 to 2022 inclusive, is made up of 4,430 admissions, of which 187 infections. So the point I'll make here is that there is the tendency, and I will accept it, that at the face of it, you would look at data points and go, you have 5 data points, you have 8 data points. They don't seem like enough
To do a correlation.
to do a correlation. You can. I wouldn't blame someone for asking the question, shouldn't I have 100 data points?
Well, indeed, that was going to be an next question, so carry on.
Sure. And what I should remind myself and others is each of those points is in itself a aggregated is the product of, in the case of infections, a lot of infections and a lot of admissions, and in the case of water, a lot of water samples for those years, and for most of those years, a lot of water samples which were positive. And so it's an artifact of aggregating a lot of data into yearly points that lends one to believe that you are really just dealing with 8 or 5. But in fact, what you're dealing with is, as I've said, and what the correlation coefficient is based on, is it's looking at 500 water sample positives, or 4,759 water samples. How does that, over that period, compare to 187 infections or 4,430 admissions? That's the numbers we are talking about here.
So you reject the suggestion that because there are 6 years involved, it's just not possible to do a correlation analysis. However, you need to explain, I think, why you didn't look at 2021 and 2022.
Sorry, I failed to hear that question, Mr. Meng.
I think you need to explain why it is that you stopped the water positivity result analysis at the end of 2020. You don't continue this analysis on into 21 and 22. Why is that?
And I will remind myself of this, but I think it would be useful as a reminding myself to, I think, go back to page 31 of my report, where I'm talking about section 8.4, well, QEUH and RHC water sampling data. And in fact, so lucky for me, the point is the first point, which is 8.4.1 on page 30, which is that NHS GGC, by way of what I received, which was called the Dr. Chaput spreadsheets.
Yes.
There were 18 of those spreadsheets, 1818, detailing water sampling data for the period 2015 to
So can we go to page
January,
31 on the document, please?
to January of 2021. The first point there. So that is all the data I had. And so what I could do was, rather than include 1 month of 2021, which would not be sufficient as a figure for that year, I calculated the water positivity for each of the years 2015, 16, 17, 18, 19, and 2020. And I stopped there.
Because you've got a partial year in 21.
Yes, exactly. I mean, for 21, I only had 1 month. I should further add that the task of putting together the water positivity data was in itself a job and a half, in that I note this in section 8, is that I was dealing with 18 spreadsheets. It was clear to me from the very beginning, and of course I knew, that this has been compiled by different stakeholders, because the formats were different. The manner in which the data had been input was different. The rigor with which the data, in terms of what kind of water sampling had taken place, where it had taken place, and what in fact were the results at the end of it, were for some years, to me, incomprehensible. It got better for 2017, 18, and 19, but it was because, so for example, I mean, one of the fundamental issues I had with this was the variable names at the top of the spreadsheet for each of the spreadsheets, or for most of the spreadsheets, they were not matching.
So the names of the wards.
The names of the wards, the ways in which the testing results had been input, the manner in which, or the language used to specify whether a water result was positive. What was it positive for? The manner in which a water positive test was indicated. So sometimes you had had the organism name and nothing more. Sometimes, and a lot more often after, I think, 2017, you had the TVCs. A lot of the columns that I would have liked to have seen with information were blank, which meant that it wasn't immediately so accessible to me whether a water result was negative or positive.
Right. So you had all this problem of assembling.
You had these huge issues with it.
But did you actually use the figures such as they were
Yes.
for 2015, 16, 17, 18, 19, and 20?
No. I used them for 2015, 16, 17, 18, and 19.
Why not use 20?
And I did not use the figure for 2020. And I did not use it for two reasons. One very significant reason is that there was a considerable decrease in the number of water samples which were sent to the lab in 2020 as compared to 2017, 18, and 19. There was a huge drop. And I think we can all figure out why that drop was. The drop was...
A drop of about 20%.
Yes. One of the reasons is because we all know that we got hit by COVID. And in my head, I was wondering whether that played a role in terms of being able for the contractors or whoever do the water sampling, because you have to physically be able to collect the water sample. Did they have any issues with gaining access to the ward areas during the height of COVID?
I appreciate that. I just wondered if you could explain if that's an approach that you think is appropriate for 2020. Surely one should have ignored the figures for 2016 because there's effectively no testing at all in 2016, or very little. So whatever's going on there, there's a reason. We've heard some evidence about it might be. It's not COVID, but it's nothing to do with. It's complicated. So if you're going to ignore 2020, why did you not ignore 16?
Yeah, I agree. And I'll tell you why. Because so let's go back to the first point. So in 2020, the world changed in the sense that the context within which I am accepting that water sampling was taking place in 2015, 16, 17, 18, and 19, in terms of how a NHS trust can operate, is different to the world that we saw ourselves in 2020. And so the 2020 set is from a context within a hospital that is now operating within a very different set of rules and context to the previous years, if you see my point.
See.
So, because the pandemic had some fundamental some fundamental ways in which to change the context, and so I draw a line between the pandemic period and the pre-pandemic period, because I cannot or I need to be conscious of the fact that the pandemic period may have introduced a factor such as access to areas, which was not the case for any of the previous years, if you see what I mean.
Yes. Okay, so you didn't include 20, but you did include 16.
Yes, and 15.
And 15.
But in full recognition of the fact that water sampling in 2015 and 16 were at levels that were far less than what they came to be in 2017, 18, and 19.
Does that not undermine the benefit of the correlation? Because you told us at the beginning of your evidence that there are, 4,000 samples. positive samples over the whole period, and there are tens of positive samples in those 2 years, does that not run the risk that that end of the correlation calculation is somehow undermined by lack of sufficient data points?
So I think you have to go with what has been presented to you, and you have to do the best with what is provided. There are things that I can adjust for, which is evidence that the context within which water sampling can be taken has changed because of the pandemic and the restrictions which were put on. So on people who were not clinicians and not immediately, involved in patient care while accessing these areas. But I do not see that in 2015, 16, 17, 18, and 19. So I went with the assumption that all areas were open to be tested. And I recognized the fact that the testing was less in certain years, and then it was escalated in other years. But what I'm not taking into account is just the water sample for positive numbers, in the same way that I have not just relied on the infection incidence. I am providing a rate of positivity.
So this is the same idea. You take the number of positives divided by the number of tests.
Yeah. So exactly. So you weight the numerator for the activity.
By dividing it by the...
And the activity, when it comes to water, is the water samples which have been sent.
Which is much lower in 15 and 16.
Which is much lower. But then again, so is the numerator. But as long as I make sure that I present a rate, so it is 5%, 4%, 3%. It's per 100, sort of the way in which we do the infection rate, which is per 10, per 1,000, because a rate can adjust for the differences in the number of samples you have sent.
Okay. So you made these assumptions and these steps, and you've then done your comparison. I think you put the result on page 92 in your supplementary report. And I wonder if you can just take us through, because obviously you've said that you're not going to rely on the previous rate curve from the first report, which produced a Pearson's correlation coefficient in the fourth line of this paragraph of 0.07, indicating a moderate, very strong positive correlation. But then you recalculated the statistic and you came up with a different number. What did you come up with?
Yes, so I then looked at the correlation, but comparing the aggregated 2A and 6A rate of infection to the water positivity figure for the period 2015 to 2019 inclusive, and the resulting figure for the correlation coefficient was very similar. It was 0.6.
And what does that tell you about the nature of the association?
As I say in the text, that it indicated a moderate to strong association between infection rates and water positivity.
Did you rerun the comparison with interventions that you ran in the first exercise, or did you not do that for the supplementary report?
I don't think I did that for the supplementary report. What I will say, if you allow me, two things. That I'm conscious that there was a change in the correlation coefficient. It went from 0.7, which indicated a moderate to very strong association. And you will remember that the closer that number gets to 1, the stronger the association. Yes. It dropped slightly to 0.6, and the consensus from the literature is that that should be interpreted as a moderate to strong association. What I did not include here is the confidence intervals. So,
yes, I was
around those two were confidence intervals. But I do have them at hand. The reason why I did not include them within that is for one reason, which is that is normally a statistic that is used when comparing what is happening within a smaller sample to say something about a larger group. So for example, if you take into account the voting analogy
in an opinion poll.
Yeah, opinion poll. If you have 10 people and you know that they have voted in a certain way, that you need some confidence intervals around that, because that gives you a sense of where the true value lies.
And that's a margin of error we hear about.
Yeah, in the population.
Right.
Because normally what you're trying to do is you're trying to run some statistics, and that's what the word statistic means. It is that you are running the calculations on a smaller sample to be able to then say something about a larger sample.
Right.
Right. This is not what we're trying to do here. Here, we're just dealing with the data on the ground, which we are using to say something about what was happening in that context and in that context only. If you see what I mean.
Yeah.
I have not used it, and neither can we use it, to say something about other hospitals or the population as a whole.
That wasn't the purpose of the exercise.
Yeah, exactly.
Right.
But for the purpose of completeness, I do have the confidence interval.
So what is the confidence interval on that 0.6 result?
It is tight, which is 0.59 to 0.61. Which
so
means,
that means the range is from what to what, because we'll need to have this clear.
So it's 0.59
yes.
to 0.61.
I see.
With the correlation coefficient at 0.6. Now, what does that say? The rule is that if you have wide confidence intervals, it means that you do not have enough certainty of the statistic, because that statistic could be anywhere on that scale. So you have a wide margin of error. If you have narrow confidence intervals, and here we have very narrow confidence intervals, it's a 0.01 on either side of the statistic. So the confidence intervals go from 0.59 to 0.61.
Right.
And what that says is then you can be pretty sure that the value of 0.6 is firm, and the underlying framework of that is the fact that 0.6 is based on a lot of data.
Okay, what I want to do now is to pick up what conclusions you feel you can make.
Yeah.
And then we'll look, if you don't mind, briefly at the use we might make of the other reports that you've looked at. I don't want to go into them in huge detail, but in respect to other reports, I'm simply going to ask you what's what's interesting that we might want to draw out for our own purposes. So just in respect to the conclusions you make, if we go back to your hypothesis, which was on page 13 at 5.7. So your hypothesis was that there existed a positive association correlation between the occurrence of patient infections with environmental organisms and the presence of environmental microbiological contamination at the hospital between 15 and 22. Now, what, in broad terms, is your conclusion in respect to that hypothesis?
That I accept the hypothesis that there is a strong association between the exposure variable, which is the water contamination, and the occurrence of infections from environmental bugs in the Schiehallion cohort.
And within the exercise, are there any particular aspects of the different comparisons you carried out, both between Schiehallion and the comparator hospitals, and looking at rates of change within the Schiehallion data you had, that particularly support that conclusion that you should draw to our attention?
So a couple. That there is that we look, so in line with direction 4, we have 3 outputs. One, that when you look at the trend in the rate of infection, of the Schiehallion unit, that there is clear from the data that you had unusual peaks that were not in line with either what the Schiehallion rate experienced so before or after, and was not in line with what comparator units were experiencing at that time.
Okay, that's any other particular observation?
Now I've combined, the first two into sort of like one statistic. So the second one would be that when I ran the correlation coefficient, both using the admission data which was presented to me to begin with, and then the corrected one, that the correlation coefficient itself, based on a large number of data points, which says something that is quite that you have a moderate to strong association at a correlation coefficient of 0.6 between the time series, that is the water positivity time series, and the time series in terms of the rates of infection, which makes me move to accepting the hypothesis that the rate of infection is not independent of the exposure.
Right. I just got a few remaining criticisms to put to you. Two. I think you might have already said you've said this, but I want to put it to you in terms. apart from in the water positivity rate calculation, you've not actually used any other obvious statistical tools here. Am I right? And does it matter?
Well, I would argue that everything that I have done from beginning to end has made use of everything that I have that you can possibly use in terms of tools to understand the relationship between two variables.
Sorry, carry on.
So, and that one tool is to understand what is the incidence rate, which is the rate of infection. The other tool is the comparison of that infection rate in the cohort of concern to comparator units. The third tool is to employ, and we did that in terms of what is the magnitude of the difference. The fourth tool is to then look at the specific tool around the coefficient of correlation. And these are the tools which make themselves available to this kind of analysis.
Thank you. Now, what I want to do now is to move on to look at some of the other reports. Might take about 20 minutes. And then we'll have a break to enable core participants to see if there are any questions they would like me to ask.
Sure.
Now, you've had to look at a number of different reports that we've shown you over the last few years, and you've referred to some of them in your reports already, and I'm not going to go over old ground. And also, we've had evidence from Dr. Kennedy, Ms. Imrie, Ms. Rankin, amongst others, and Dr. Peters and Ms. Harvey Wood about their pieces of work. So we have that on board to take into account. But I want to just walk through the various groups of them, and I'll group them by authors, I think, for clarity.
Sure.
So the first one is the two pieces of work done by Kathleen Harvey Wood and Dr. Christine Peters in 2018. I'm going to use the PowerPoint presentation to look at, but I understand there's also a report. The PowerPoint presentation is Bundle 27, Volume 6, Document 9, page 107. And just for completeness, the report, if anyone needs it, is Bundle 19, Document 19, page 143. So that's definitely the wrong place. Bundle 27, Volume 6? Yep, I've got that wrong. So give me a moment to get the right one. Thank you. Which bundle was that? All right, sorry. So this report, I think you've had an opportunity to read this.
Yes.
And maybe we just step through 2 pages, 3 pages, to look at this, which shows I understand, the percentage of positive blood cultures through the report. Now, you've read these presentations.
Yes.
I've obviously noticed that they use as a denominator positivity of blood cultures. Is there anything useful you would see within here that we should be looking at as a piece of epidemiological evidence that sort of stands out, either positive or negative, in respect to the hypothesis that you've just discussed?
The thing I would take from this, this analytic, is what you can see here, although it hasn't been labeled, which is the red line which is slanting upwards.
Yes.
Which is the trend line, which gives you the overall feel in terms of what the positive blood cultures looked like over the period from June 14 to July 18. And what that tells me is that the rate of positivity was increasing over that period. That the line of best fit is slanted upwards, which is indicative of the fact that the percentage positive rate was lower from June 2014 to about March 16, and there are a few exceptions to that in a few months there. So particularly October 15, Jan 16. But then the trend line picks up this escalation, and I would use the word here, well, overall escalation from July 16 onwards, bar some months where the rate of positivity drops, with what you can observe are these unusual peaks in Feb 17 and April 17, and then of course in December 17 and March 18. The assumption here is that, and I think it's been adjusted for, is that it's a rate of positivity. So of the blood cultures being sent, that's the rate of positive. It also, I mean, if I were just looking at this, you always take the rate of positivity as blood cultures as a proxy marker for the risk that is affecting the patients. So it says to me that the larger the proportion of blood cultures which are coming back positive is a marker for that the patients are suffering from more infections. But the caveat is that you could be sending in more blood cultures because you were more worried about these patients. But you still need the patient to be positive for the blood culture to come back as positive.
While we're on this slide, I wanted to ask you a general question which applies to lots of these reports, is that many of them use a data set that runs back in time before the opening of the hospital. Indeed, Dr. Kennedy made the criticism of this trend line as you shouldn't have had a trend line that runs before the change, and you're sort of nodding.
Yeah, I agree.
But I'd like to understand if you've got any thoughts about how we should treat this left-hand third or quarter of these graphs. It repeats, not here, it's in Dr. Kennedy, it's in HPS. There is a segment of data from York Hill, the old York Hill. It's just a year and a bit sometimes a bit longer. Do you have any advice about how we should look at that? I mean, a good example might be if we jump to Dr. Kennedy's second report, bundle 6, page 107, which is, he gave some specific evidence about. So Dr. Kennedy gave, if I recollect his evidence correctly, we discussed this with him, this graph of selected gram negatives. It's a much shorter list than your list.
Yes.
And I asked him what we should draw from this graph, what stood out, and I seem to recollect he noted the existence of some sort of event happening in early 18, in early 17, and in 13. And when we were looking at the SBC graph for the HPS report earlier on this morning.
Yes,
There was things going on the left-hand side.
yes.
How should we approach that evidence, the information? Should we think about it in a particular way? Should we take account of it? Should we ignore it? What should we do with it?
So my immediate reaction to it would be going back to what is the question at hand. And the hypothesis we are trying to test here, which is there a relationship between the environment that came to be in the new build and the rate of infection? If you stick to that, then the consequence of answering that question is to ignore everything that came before it, because the setting is not the same. The patients were moved into the new build in June of 2015. We are the question at hand here is how related, or what is the association between the environment with the water positivity being the variable of choice and the infections. And so it would not be advised, in fact it would be wrong to in answering that question, you would have to start from the point at which the patients went into the RHC, the new build.
But what about the idea that it's the same patients, broadly speaking? And putting aside for a moment the evidence we've heard about the different nature of the bacteria involved, which we've had a lot of evidence about that. You're not a microbiologist, so I'm not going to ask you about it. Putting that aside, is there not some information that we can derive from the various charts? I mean, this is a good example here, where the left-hand fifth of this chart, less than that perhaps, is before the move, and therefore some reassurance can be derived that for a significant period of time, in this case up until January 17 on this chart, there's no real change in what happens. Is there anything wrong with that as an approach?
So I wouldn't agree, because I think, and so I'll go back to what we are trying to ask here, is we are asking, is the rate of infection in the patients who moved into the new build, what is the association between the rate of infection and what is what is eventually a specific environment, a physical thing, which was not the same at York Hill. So the only thing that you can do here is that if you were, you were pushed to do something with the rate per 1,000 bed days of the Schiehallion, of the pediatric hematology cohort at York Hill between July 13 and prior to the move to the new build, would be a mean rate of infection. But a mean rate of infection for that population in a setting that is different to the setting that they went into.
But isn't that just what you did with the comparator units? You created a mean. I mean, we don't know. We've had no evidence about the nature of the buildings in Oxford or Cardiff or whatever. Isn't that just the same thing?
I
It might be a difference of scale. I accept that, but it's
sure. I think the difference of scale matters, and it matters quite a bit. Going back to why I did not compare the rate of 2A per 1,000 bed days to just one other comparator. In the same way, it would not be sufficient to just compare the rate per 1,000 bed days in the Schiehallion, in the new build, to itself, if you want to extend that point, to what it was in the old build. Because it only lends itself to so much. And what it lends you, and that sort of comes back to why I am not a believer in just using SPC charts, is ultimately you are comparing yourself to yourself, and the true nature of your rate of infection is to contextualize it within what is happening in the world around you, i.e. to other comparator units. That is the only real way in which you go that, these are 4 or 5 units. They are all taking care of pediatric hematology, oncology patients. Over the same period of time, with certain assumptions, of course, how do our rates compare?
Yes.
I think that that comparison externally is is key to being able to understand where you are. I mean, it's sort of the analogy that I only know how tall I am when I compare myself to someone shorter or taller. I mean, otherwise, I'll just think, I am, I'm fine.
You're the same height you were last week.
Yeah. So yes, exactly. But the point is that I can then go on to say that I am shorter than Fred, but I am taller than Mansi.
Right.
But it is as it is as core as that.
So you mentioned SPC charts, and I suppose that means I'm now going to talk to you about SPC charts.
Sure.
So if we can go on to the HPS report on bundle 7, we go to page 227. Now, I know, and we all can read what you think about SPC charts. You've said it in your report. If we go to the bottom half of the page. And over this page, if we go on to page 229, we see indeed a chart.
Yes.
Figure 4. Now, if we can take as read your critique of SPC charts, we've read it, we've put it to various people, we've heard evidence. I just want to work out what we can do with them, given your concerns. And I suppose I want to use an example. If we just look at this one, which is an SPC chart for the gram-negative case definition for HPS data, July 13 to September 19, and you'll notice there's a circle, ellipse, drawn around the incident rate per 1,000 occupied bed days in late 17, early 18. And if we go back to page 227, bottom of the page, do you see it starts discussing gram-positive organisms at the bottom of the page? We go over the page. It says, when using the gram-negative case definition, an upward shift with a run of 10 data points above the mean was observed from March to December 17 within the upper warning limit breached in various dates given, figure 4. Now, I absolutely get that, A, you don't like SPC charts because they have a baseline that is themselves, and you have other criticisms of them.
Sure.
But we have a lot of this material.
Sure.
Collected at the time, and people have given their opinions about it, and I'm pretty sure they've made their decisions based on these. How should we use this information? Not only the graphs themselves, but this narrative form here. I'm taking it you don't think it's entirely useless, so what should we use it for?
So, and I'm taking your question as you're asking me what is the usefulness of SPC charts within the broader context, not just for the inquiry.
Yes. Well, no, I'm taking it the inquiry. It's about what we use it for.
I think so. I've written down 2 points, and I will just sort of let's start with that as a starter for 10. Is that just because the data points do not fall outside the upper limit, and at which point they will then be termed a abnormal variation, doesn't mean that they are not of interest and therefore don't warrant being looked into.
Okay.
So that's one. And the learning from that is that SPC charts tend to give the reader, in my opinion, a sense of comfort, or they can lead to that let's wait for rates of infection to peak above the parapet, which I have to stress is let it peak above the worst possible scenario,
Right.
which is what the upper limit is. The upper limit isn't there to say that's when you should see me. That's the worst possible scenario when you should be seeing me. But use that as a marker to go back and go, what caused me to peak out then? If
So
you
you
see
look
what I
at the
mean.
point of change.
Yeah, it's just a proxy marker that things have got so bad that now my rate of infection is above the upper limit line. Seems so. So that's one. So the learning from that is don't wait for the upper limit line. That what is important is you can view the variation, and if you see a lot of peaks, look into it. Don't wait for it to creep up the parapet. And my second point, but I made already, which is in a vulnerable population such as the pediatric hematology unit, cohort, do not. What I feel, the sense is that the SPC charts, and therefore what it lends the reader to do is to wait for the data points to fall into the realm of the abnormal or the unusual to suggest something is wrong. So, in answer to your question, what can you take from it? Unfortunately, I wouldn't take much from those charts. But a tweak to those charts would make more sense, which is, and is back to my point about, so isn't it quite hard to read a graph that looks at month-on-month rates of infection because of the variability and the busyness of that graph? It would have been a lot better if these SPC charts would have looked at a rate of infection by quarter, because then at least it gives you that a sense of what 3 months are telling you. And I say this when you're looking at it retrospectively. When you're looking at things in a live manner, so if you're using SPC charts and you're going, okay, it's the month of July, the SPC chart is running live. What is it telling me? Don't wait for the peak to peak above, the upper limit.
Okay. I want to look at one more report, which is a presentation that you hadn't seen when you wrote your reports, but I think you saw it this week, which is done by Dr. Kennedy and Ms. Rogers to the, I think the IMT on the 20th of September 2019. That's bundle 27, volume 13, document 13, page 77. Now, I think it's important before discussing it to put it in its context. So its context is September 19. So that is a year after the decant. I suppose it's also relevant to spot there'd been a change to the IMT chair. There'd been earlier in that month the suggestion from the then lead ICD and other microbiologists that the wool was microbiologically safe. There'd been some suggestion from HPS that they weren't willing to accept that at the time. And then this is produced. And Dr. Armstrong gave evidence that she felt it was quite an important piece of work. And I'm conscious that it refers to success with CLABSI data, but I wonder if there's anything that we should take for it as an inquiry in trying to understand what's going on in the second half of 2019.
Sure. Would you like to sort of show me a specific
Yes.
analytic, and then I can sort of
So I felt there's only about 4 graphs in here. The first one seems to be CLABSI rates, but it has gram negative within it.
Yes.
Is there anything that can be taken from the gram negative CLABSI data on page 78?
Well, I think what you can take from it is that if you look at the blue line, which I take here as the rate per 1,000 line days of CLABSI.
That would include gram positive, gram negative, everything.
Yeah. That if you look at Jan 15 to about May 17, the general the trend over that approximate 2-year period is one of escalation. More or less, if you sort of, and I'm trying to, in my mind, aggregate the months into a year or a quarter, it settles, it remains high. Something the mitigation steps were brought in, and the reduction plan, the CLABSI reduction plan has then led to a decrease. If you look at the trend from about May 17 to July 19.
This is the blue line.
Yes, exactly. The blue line, there's been the general trend has been downward. So the CLABSI rates went up and then they went down. But interestingly, over the period when the CLABSI rates were going down, look at what is happening to the rate of gram negatives. Something there suggests that the CLABSI or the steps to mitigate line infections was working with regards to bugs that were other than gram negatives.
In a sense, the gram negative is the only bit that's left by the end.
Yes, and that there are other causes for the gram negatives that were not just the fact that some of them were linked to line-associated BSIs.
And I just wondered whether page 85 and its associated table, which is page 86. We go back to 85. And I suppose we looked at enough of these charts over the last 10 weeks. Is there anything you see in there that we should be taking account of to understand what's going on, bearing in mind the bacteria that are included in that list?
And I presume that the rate here is not based on as comprehensive an infection list as I have in my reports.
I think you look on page 86, it doesn't seem to have as many cases.
Yeah. And if we go back to 85, so again, it would be much easier to look at this on a year-by-year basis, because I mean these
because you would be able to do an almost direct comparison.
Yes, exactly.
Between your work on bed days.
Yeah, exactly. So I mean, almost by if you could if you could superimpose mine on this, and we can have a look at it. But but observationally, so graphs should work. I mean, they are made to be able to impart what the data is telling you in a sort of visual manner. Well, I'm struggling at that, but
I'm just wondering whether
what it is telling me is that the rates of gram-negative, the blood cultures, is on the way up if you take into account where the data points are in September 15, November 15, Jan 16, and you compare it to where they end up in September 17, November 17, Jan 18, March 18, May 18, and so if you take into account those two as the start of the pipeline and the end of the pipeline, and you sort of drew the line of best fit, it would be slanting upwards.
Because it occurred to me that there's an interesting question which I regret to say I haven't put to Dr. Kennedy, because I didn't think I got this until after he gave evidence.
Yes.
Is that if we look at the definition at the top, it's the crude rate of all gram-negative blood cultures. Now, when I read this, I assumed, and I don't know whether I'm right here, that it will include, since it goes 2A, B, and Ward 6A, it will include the day cases. So infections from day cases. But the rate is per occupied bed days.
And one point, if I can, because as soon as
I've
you
interrupted you enough, so keep going.
No, because as soon as you said gram-negative, I was looking for that next word, which is are these environmental?
Well, can I let you look at the next page when I finish the sentence? Because could it be, if we just take this on trust, that the numerator in this table is all the gram-negative, come back to what that means, infections for both day cases and overnight admissions in 2A, 2B, and Ward 6A between November 14 and July 19, divided by the number of occupied bed days, accepting that, remembering Professor Stevens, you only get to be an occupied bed if you're admitted.
Yes.
Might that not suggest that, well, these peaks are quite high compared to, we go back to Bundle 21, Volume 1, page 771, which is your calculation with a larger data set? Because you've got peaks of 6 and a bit per 1,000. If we go back to the previous slide,
they have peaks of
12. Now let's allow you to answer your question.
And 13. And
going on to the next page, you're not a microbiologist, but this is a memory test in a sense. That list of species, how much connection does that have to the sort of species that you were considering in your work?
Well, I mean, I think the blunt answer to that would be that there are less here than were in my list.
But are there things in here that weren't in your list?
I will have to be reminded, I think, at the end.
Can we go back to your list, which is on previous bundle, page 25?
Yes.
So we can put on the screen bundle 27, volume 13. And then you've got the hard copy, I think, of your report.
Yes.
But the impression I formed was that this is not as many infections as your list, and I may be wrong.
Yeah, the numbers are so I had 187 in total. And someone would have to do a bit of mental maths to
Well, we can do it for at least for one of them in the time we have, which is if we go down to on page 25 of bundle 27, 21, volume 1, you had 16 cases of Enterobacter clothi, and this one has, I picked the wrong one. It doesn't have any. Let's pick one with one.
No, I think it has the second from the top.
Yes, it does.
Yeah.
So it has a not dissimilar number of cases.
Yeah, it
Now,
has.
all I wanted to do from this, because I'm not making you do epidemiology on the hoof, is we've got Dr. Mumford coming along next, and Ms. Dempster coming on next week. And
Yes.
there's a question I thought I might ask them. And I think I want to make sure that I'm not getting the epidemiology daft in order to do this. So we go back to the previous page. Is it a reasonable question to ask them to look at this chart and the one on the following page, to look at your list and your report, and possibly even actually Dr. Kennedy's work as well, and to start comparing in very broad terms, not necessarily the rate per 1,000 occupied bed days, but the changes in those rates? Is that a reasonable exercise for them to do in a week's time?
I think I would lean towards the latter, which is you can compare these outputs in terms of the changes, because we're not using the same cases, and we have to keep that in mind. But what we can do is, in broad terms, ask the questions such as, are the trends and the magnitude of the differences between the sections of each of these graphs, do they say similar things?
About timing an event.
Yes, exactly.
Well, I will come back to that with Dr. Mumford and Ms. Dempster. Well, Lord, those are all the questions that I have for Mr. Mookerjee. Traditionally, we take a 10-minute break to see if any core participants have a question or two.
We'll do that, Mr. Mookerjee. I need to find out if there's further questions in the room, so I'll ask you to return to the witness room, and we should be back in about 10 minutes.
Sure, thank you.
You stand?
Ms. McIntosh.
I have 3 questions, my lord.
I understand we have 3 further questions.
Okay.
Mr. Mookerjee.
So the first question relates, I think, to the issue of use of epidemiology in managing outbreaks.
Yes.
So the question is the level of comparative epidemiology you've described typically required during the management of hospital outbreaks? And there's a follow-up, depending on your answer.
Okay. I mean, so it's a broad question. My response to that would be that every attempt should be made to compare, so that you, as someone who is dealing with these rates of infections, that you have clearly sort of marked out as being unusual or part of a outbreak or a cluster, but you should be making every attempt to compare and to contrast, and to use your your organizational links to understand more about your context.
Could it be argued that sometimes the best comparator is the unit itself, in the sense that you plot the interventions and measure the impact of the interventions? And sometimes that actually might be an easier way of proceeding. You look at the intervention and see whether it made a difference.
So I'll still stick to the fact that the first point is very well important. But I agree that the second point is also important, but I'll expand on that, in that it's only as good as the surveillance that you have going. And so what you need is ongoing surveillance. You need to be able to understand quite soon after something has happened that it has happened. And you should be moving on from incidents to rates, although, in a live, on the ground, manner, on the coalface, the incidence is what you will see to begin with in terms of clusters. And yes, if you see a cluster of cases and you do something about it, that is essentially what we do in the clinical circle. If you see that a ward has 5 or 6 cases, you tag them as a cluster because they've happened in the same, at this, in a space. So roughly at the same time. I mean, you have definitions for that. 2 cases within a period of 7 days, 3 cases within 14 days. So you presume they are linked unless you get evidence that they are not linked, that they are a marker of something is going on. But either there has been transmission, or there has been transmission from the environment to the patient. But you can then institute some steps, and the go-to is to then look at what do the mitigation steps do to the outcome. If the cases go down, you have some sense that what you've done in terms of mitigating has worked. If they don't go down and they continue, whatever you have done is not working, because you either incorrectly identified the source of that infection, or maybe the reason for for that infection, the few cases requires more than a single sort of step. It requires a multitude. It requires a multimodal way of doing things. So I agree, but it requires you to have your finger on the pulse, and the key, the pillar here is the data. The data has to be really good. You need to have people who understand the data and who are able to turn data into something that is meaningful for clinicians. And the clinicians have to have access to that data in a live manner to be able to not just pick up things that are going wrong, but then to do something about it, and then for them to get some reassurance that what they've done has worked.
Right. Now, a related question to the first question I asked you, I realized I should show you bundle 7, page 231, which is the sorry, not 231, page 267. In fact, 231 will do. We'll stay with 267. It's the same paragraph. So this is the HPS report from November 2019. It's the comparison with other health boards. I'm not going to go into the detail of what is observed here, other than to note that what appears to have happened here is a comparison between the overall hospital rate of positive blood cultures between the RHC and the combined Aberdeen Children's Hospital and the Edinburgh Children's Hospital. This seems to be of significance to some decision makers and is widely repeated. And I wondered if there are any risks that one has to take account of when relying on such a comparison exercise between the whole children's hospital and other whole children's hospitals in this context.
Well, in this context, and one of the central themes of the context is we're looking at what are we asking? We are asking, is there anything unusual going on in terms of the infection rate in the specific cohort, which is the pediatric hematology, oncology cohort? To that end, I wouldn't take the overall hospital rate at the RHC and compare it to what I think is the overall hospital rate at 2 other centers, because that does exactly what it says on the tin, and it doesn't answer your question. And the question is, are the rates of infection we are seeing within the pediatric hematology oncology unit, are they unusual? Should I be doing something about it? And because the overall hospital rate will, at the RHC, at the children's hospitals, will not be specific for that cohort and will give you an answer that is diluted.
Okay, what I want to do is move on to the next question, which is if we go to your report, that's bundle 21, volume 1, page 21. You listed the information you sought and obtained from 4 hospitals. Would it be fair to say that you have no knowledge of the nuance or detail or the differences between the patients in these 4 comparator hospitals and each other and the Schiehallion? You can't comment on anything to do with the distinction and difference.
No, I cannot.
Now, you've already explained why you don't think that matters, but do you think you should have made that clear in your report, that this is not you can't make a view about whether there is truly a comparison to be made between Cardiff and the Vale or Oxford, and other than the fact they are just, in general terms, pediatric oncology?
Well, I think in asking that we want that here is what we are trying to do, And what we want from the comparator institutions is infection data and the activity data that is specific to the pediatric hematology oncology unit. We've remained faithful in what we want from the comparator sites. The way that we went about it is we sent this to every single center that we knew had a pediatric hematology, oncology, had a center that, and what we received was something which was not biased by us. We received information from X numbers, and we then had to take what we perceived to be a complete set of data. And in doing so, in epidemiological terms, it was good that we ended up with a admission number, a total aggregated admission number from all of those 4 hospitals for those 8 years, but more or less, which was a pretty high number. I haven't added up all the 4,000s and the 2,000s, and so similarly, we got a high number of infections. So I'll go back to the fact that we aren't comparing one hospital to another. We are comparing our interest, so which is how do we contextualize what is happening within the Schiehallion, and we're comparing it to an aggregated rate over a long period of time, 15, 16, 17, 18, 19, 20, 21, 22, so ultimately 4 other hospitals, lots of admissions, lots of patients. And so that adjusts for the biases and the confounders, which, comparing 1 to 1 will not.
So what I wanted to do is one final question. It's back to this 14-day thing again.
Yes.
So it's been suggested that you're deduplicating on the 14-day basis on a different basis from NSS or indeed the UK standard. And in essence, the problem is this that's been put to me, that we go back to our example of a case on day 1, day 12, and day 18. If I understood your evidence correctly, you would count the case on day 1 and the case on day 18.
Yes.
Yes. The position that's been put to me is that the correct way to proceed is that you ignore anything that happens within the 14-day period that follows any positive sample, and therefore that the 18-day example would also be excluded because it's within 14 days of the 12-day example. Now, I realize that you've done the same thing for both comparator and Schiehallion, but how do you respond to the suggestion that you're doing this wrong? You're not following national standards.
So, so if you look at, and I share this with yourself, that there is there is a protocol on the nss.nhs.scotland the website.
Yes.
And it comes under the heading of protocol for national enhanced surveillance of bacteremia.
Yes.
It's from 2020.
Yes.
It says, and I use Pseudomonas aeruginosa as an example. A case of bacteremia is a patient from whom Pseudomonas aeruginosa has been isolated from the patient's blood and who has not previously had the same organism isolated from blood within the same 14-day period, i.e. 14 days from the date last positive sample obtained. When you put that, when you put that guidance into practice, and Pseudomonas is one of the reportable infections, both in England and in Scotland. So you report it nationally. So it's part of mandatory surveillance. If the patient came in on the 1st of November and had a blood culture, that blood culture which say you have positive for Pseudomonas aeruginosa, that blood culture would be reported to UKHSA or to HPS. If that patient, for whatever reason, had blood cultures taken every single day from day 1 to day 14, it would be considered that those blood cultures are indicative of the same episode of infection that we were told about from the first blood culture that we reported.
But wouldn't you wouldn't report the blood culture on day 15 according to this criteria? Is that, I understood that correctly?
So in practice, how the reporting works is that you take the difference in the date of collection of the second sample, and you subtract it from the date of collection of the first sample, or the first reported sample. And if the numerical the value is more than or equal to 14, you report the blood culture, the second blood culture. If the numerical value between those two blood cultures is 13 or less, you don't report it because that blood culture is still indicative of the episode of infection that we told UKHSA or RI about using the first culture. But and for surveillance, you have to draw these lines in the sand, and it can well be argued that a episode of infection can travel longer than a 14-day cycle. But in the real world, you have to make some decisions. And in the real world, if the numerical, the difference between the collection dates is 14 or more, you report that sample with that collection date because it is now indicative of a new episode of infection.
I understand that, but the risk of confusing us all at 4:45 on a Tuesday night. If there are 3 infections, the first infection's on day 1, the second infection's on day 12, you don't report the second one because the difference is less than 14. Understand that? You have a third infection on day 18. Now the difference between the first one on the 1st and the third one on the 18th is more than 14. But the difference between the second one on the 12th and the one on the 18th is only 6. So it's being suggested to me that you wouldn't report the 18th one because it's too close to the 12th one.
No, so it's not true, because in reporting, and I have led on the national reporting for the past 14 years, that UKHSA will ask you very clearly, because remember, this is the only lens that they see.
I think that's why I'm being asked the question.
Yes, exactly. So is we saw that you uploaded something that is a proxy measure for a patient that has suffered or is suffering from a bacteremia on the 1st of November. any other a culture from that patient where either the genus, so in this case, which is Pseudomonas, or the species, which is Aeruginosa, if that remains the same, we do not want to see any samples from you. So up until where the sample is collected more than or equal to 14 days after the first. The only time that we want to see a sample from you between those two dates is if something about that bug changes.
No, I understand that.
I think that's an important thing, because from a surveillance point of view, what we are all trying to work out here is how many episodes of infection do patients have nationally?
But that's not what you're doing in your study.
Well, here I'm applying the definitions that we use nationally to work out how many unique patient episodes of infection did we have for the period 2015 to 2022.
So I think I understand that. And what I think I want to wrap up with is, if there is a difference between the way you've approached this and the way of which other people in Scotland have approached this, I want to check that the way you approached it for the Schiehallion infection rate and the way you approached it for the comparative infection rate is the same.
Yes.
Well, I have no more questions for this witness.
Mr. Mookerjee, that is the end of your evidence, and you're therefore free to go. But before you go, thank you for your attendance today, and thank you for the considerable work that will have gone into these reports, supplementary report, the addendum to the report, and the consideration of the additional questions. So can I repeat my thanks, but can I also repeat that you're free to go?
Okay. Thank you very much.
Now, as I understand it, Mr. McIntosh, we plan to resume tomorrow at 10 with Dr. Walker.
Who I'm pleased to say is in the jurisdiction.
Right. Well, we shall, all being well, see each other tomorrow, and I would wish everyone a pleasant 5th of November.
Please stand.